Welcome to Auth Explained, a short series on how modern web authentication actually works under the hood. In this first episode, we're tackling one of the most common building blocks you'll run into, the JSON Web Token, or JWT. Think of it as a tamper-proof ID card for the web, a small signed piece of data that lets a server know exactly who you are without ever having to check a database. Before we get to the solution, let's sit with the problem. HTTP is stateless. Every request arrives as a blank slate with no memory of the one before it. So you log in once, and on the very next request, the server is asking, "Wait, who are you again?" You could check the database every single time, but that's slow and it doesn't scale. The real question is, how does the server trust that you're already logged in without that constant lookup? That's exactly where the JSON Web Token comes in. In one sentence, a JWT is a signed, self-contained token that carries claims about who you are and proves it can't be forged. Think of it as a tamper-proof ID card the client holds on to. It brings its own data. Any tampering is detectable thanks to the signature, and the server doesn't need to keep a session sitting in memory. To make that concrete, picture a festival. You check in once at the gate and get a sealed wristband. From then on, any staff member can just glance at it and wave you through. Nobody calls the front gate. Nobody looks you up on a list. The wristband itself is the JWT. What it says about you is the claims. The seal that makes it unfakeable is the signature. And every staff member checking it is any server in your system verifying the token. So let's crack that wristband open and see what's actually inside. A JWT is really just three base 64 encoded chunks glued together with dots: header, payload, signature. The header announces which algorithm did the signing, something like HS. The payload carries the claims, the actual statements about who you are and when the token expires. And the signature is the tamper-proof seal that proves the first two pieces haven't been touched. And once you decode it, there's no magic. It's just JSON. The header is a tiny object naming the algorithm and type. The payload holds your claims. Sub tells you who the user is. Role tells you what they're allowed to do. And exp is the Unix timestamp marking when this token stops being valid. The signature down at the bottom is an HMAC of the header and payload, mixed with a secret only your server knows. And that signature is really the whole point of the design. The server takes the header and payload, runs them through a signing function with its secret key, and the output gets appended to the token. Now here's why that matters. If anyone changes even a single character of the payload, bumps their role from user to admin, say, the signature stops matching. The server recomputes it on every request, sees the mismatch, and throws the token out. No secret, no valid signature. So let's trace what that actually looks like in practice. The user logs in once with their username and password. The server validates them and hands back a signed JWT. From there, the client just attaches that token to every request it makes, usually in an authorization header. The server checks the signature, and if it holds up, the request is trusted. No session table, no database round trip. The token carries its own proof. Now, to really appreciate why JWTs matter, it helps to compare them to the classic approach, server-side sessions. With sessions, the state lives on the server. Every request means a lookup in some session store, and if you're running multiple servers, they all need to share that state. JWTs flip this entirely. The state rides inside the token itself, so any server can verify a request on its own, just by checking the signature. The trade-off shows up at revocation, though. Deleting a session is trivial, but a JWT stays valid until it expires. We'll come back to that one. And speaking of trade-offs, this is a good moment to talk about the sharp edges. First, remember that the payload is just base 64 encoded, not encrypted. Anyone holding the token can read it, so never stash passwords or secrets in there. Second, as I just hinted, you can't easily revoke a JWT once it's issued, which is why short lifetimes paired with refresh tokens are the standard play. And third, watch out for the infamous algnun trap. always reject unsigned tokens and explicitly pin the algorithm you expect. That refresh token pairing I just mentioned deserves a closer look because it's really two tokens doing two different jobs. The access token is the one you actually send with every API request. It's deliberately short-lived, maybe 5 to 15 minutes. So if it leaks, the damage window is tiny. The refresh token sits safely tucked away, days or weeks long, and its only job is quietly minting a fresh access token when the old one expires. Short access plus refresh. That's how you get both security and a smooth user experience. So once you've got these tokens, where do you actually put them? Local storage is the easy answer, but anything in there is readable by JavaScript, which means a single cross-site scripting bug hands your token to an attacker. An HTTP-only cookie keeps it out of JavaScript's reach entirely, much safer against XSS, and keeping it just in memory means it vanishes on refresh, but it never touches disk. The pattern most modern apps land on. Access token in memory, refresh token in an HTTP-only cookie, best of both worlds. Before we go further, let's clear up a few myths that trip people up constantly. First, a JWT is not encrypted. It's signed. Anyone can paste that token into a decoder and read every claim inside, so never put secrets in there. Second, JWTs aren't automatically more secure than sessions. They're a different trade-off, swapping easy revocation for statelessness. And third, that signature isn't hiding anything. It only proves nobody tampered with the payload along the way. So, with the myths out of the way, when do JWTs actually shine? Reach for them when you've got stateless APIs spread across many servers, service-to-service calls, short-lived access tokens, or mobile and single-page app front ends talking to a backend. But think twice if you need to revoke access the instant something goes wrong. If your sessions live for days or weeks, if you're stuffing in lots of changing data, or honestly, if you're just running one modest server, a plain session cookie will serve you better. Once you've decided JWTs fit your use case, here are the tools you'll keep bumping into. JWT.io is your go-to for decoding and inspecting tokens in the browser. For libraries, it's JSON Web Token in Node, PyJWT or Jose in Python and JavaScript when you need the full JWS and JWE toolkit. And if you'd rather not build the issuer yourself, managed platforms like Authentication and Okta or the open source Keycloak will hand you signed tokens out of the box. So let's pull the key ideas together. A JWT is a signed, self-contained identity token built from three parts: header, payload, and signature, where that signature is what guarantees nobody tampered with the contents. Remember, it's signed, not encrypted, so the payload is readable by anyone who gets the token. Keep your secrets out of it. And in practice, pairing short-lived access tokens with longer-lived refresh tokens is the balance most teams land on. With that foundation in place, here's a practical hardening checklist. On the do side, keep access tokens short-lived, always verify both the signature and the algorithm, validate the standard claims like XP, ISS, and AYAD, and of course, HTTPS everywhere. On the avoid side, never stash secrets in the payload, reject any token claiming ALG, none, steer clear of huge tokens that never expire, and think twice about local storage if your app has any XSS exposure. If you'd like to keep going, this is episode 1 of the Auth Explained series. Upcoming pieces cover OAuth 2.0, OpenID Connect, sessions and cookies, and API gateways, each building on what we've done here. And remember, tokens only protect requests in flight. The servers issuing and verifying them need their own hardening. If that's your next concern, take a look at SSH Hardening Mastery over at Dargslan.com. Courses. Before we wrap up, I'd love to hear from you. When you're starting a new project, which way do you lean? JWTs or classic server-side sessions? And had it occurred to you that the payload is just base-64, readable by anyone who copies the token? Drop your thoughts in the comments. I read them all. And that's JWT. Hopefully no longer a mystery, just a tamper-proof ID card you now understand from the inside out. If this one clicked, Hit subscribe so you don't miss the rest of the Auth Explained series. We'll be tackling refresh tokens, OAuth, and session strategies next. You can also find more deep dives over at dargslan.com. Thanks for watching, and I'll see you in the next one.